top 20, and but not a finalist. And they had made these papers, and I assisted them in creating their presentations. And I, assuming that I would just be on the sidelines, admiring their work as they presented it. And so they pulled what I make an analogy to Las Vegas, where you go broke, assuming that you can make the money back in return. And so they made these papers and was not able to get the sponsorship to come to the United States. So on their behalf, I'll be presenting for them. This first one is called The Concepts for Future Robotic Mars Manned Missions, presented by me. Asanya Rao and Jayakumar Venkatesan, I spelled it if I pronounced that correctly. They're both from the Vimana Ocean Aerospace, and that's a startup company in Bangalore, India right now. Next. All right, so Martian surface, to know the information and disciplines of Martian geology, geochemistry, what else is there? Atmospheric sciences, etc. And the Martian surface itself is associated with communication difficulties. Most are affordable of robotic activities on Mars. And as you know, that most of robotic missions operate alone or with the 8-minute gap to send signals back from Earth. And so the development of new generations of computers and machines capable of incorporating a network between the Mars settlements, camps, and expert systems. The ability to analysis the Martian surface and the atmosphere of the planet for human settlement and planet exploration. Next. All right, let's begin. So as we know, robotic missions are essential for the exploration of Mars. And that's all fine and good, because through trial and error, we have found out so many things about the planet through those errors, and that if there was a human factor in these beginning missions, it would be less to be desired. Keep going. A bunch of pictures are supposed to come up. So, in lieu of this, we've always seen robotics as the front runner. Oh, sorry, back one. We've always seen robotics as the front runner of manned exploration wherever we go, and this is most important on Mars. And that when people say that robotics is going to be replaced by autonomy, and they're actually two different things. But that, as you can see, in the next 15 to 20 years, we're going to be very much alive with robotic missions on Mars, as they are all contributing to our eventual manned mission. And as you can see on the board here, you see our InSight lander, which is going to be doing seismic and internal geology of the Martian surface. And then you see the Indian Mars orbiter is also heading to Mars as we speak, being a land, milestone for the Indian Space Agency, which is fairly new. And then you see our new Maven satellite that will be doing atmospheric sciences over Mars. And then you have the the Mars 2020 rover is in development as we speak, and all of the current events with it. That is very alive and well, that robotics will continue to be present on Mars, even with people on the surface. Next. Okay, next. And so a brief overview, in case you need to keep up on your history, next, is that unmanned missions have been going since the 60s with a few nations, more just us and Russia, next. And that both mission success and failures have been present to getting probes and rovers to Mars, next. Each mission to date has been technologically successive than the previous, and getting back scientific valuable data. Next. Will continue to be a valuable asset for manned missions to Mars. And the next part here is where it gets a little intense. So robotic technologies for Mars exploration. Space robotics as a discipline is focused on more specific issues and reflects more closely the subject area covered by terrestrial robotics. Indeed, space robotics, like terrestrial counterpart, is generally divided into two subject areas. Robotic manipulators. Such devices are proposed for deployment in space or on planetary surfaces. So you see like cranes, Canadarm, and the like. Anything, and there will be future missions that can be dedicated for robotic manipulators using, doing ISRU, or something even new that I wouldn't even know about yet. And robotic rovers, such devices are proposed for deployment on planetary surfaces to emulate human mobility capabilities. They are typically deployed on the surface of terrestrial planets, small bodies in the solar systems, and planetary atmospheres like aerobots. And that's a prototype in development, according to the MANA that they've been looking into that, or the penetration of ice layers, cryobots, and liquid layers, hydrobots. Next. Keep going. Robotic consumption purposes for manned missions. This is a long list. Okay, so keep going. And science will still be prevalent to robotic missions on Mars, but robots will also have an important role in the eventual human-based Mars mission and planning. So we have this list here. So you see examples include in-situ resource utilization, sample return missions, navigational aids, beacons, hazardous exploration or emergency repairs, high-altitude meteorology and observation for manned missions already on the ground, and for simulations and training. And this, 10 minutes? Cool. All right, so we might going to skip ahead. We already went over robotic manipulators, so skip to the next one.
I'm sorry, you're not at 10 minutes.
Not at 10 minutes?
No, you're right, you have 20 minutes.
Oh, perfect. Okay, it's fine. Okay, so what technological leaps should the next generation of Mars robots undertake? So, test new entry, descent, and landing methods. And that's utilizing flight through the Martian atmosphere to complement retropropulsive maneuvers to land heavier payloads, accurate landings, space station infrastructure development, and developing a forward manned presence around Mars, and that may even provide real-time control of robotics going to the surface and satellites. Next. And future opportunities for station longevity and rotational cruise, as well as robotics for simulations here on Earth. Next. Entry, descent, and landing. So you see here, Curiosity and Sky Crane. Now, any good planner and system engineer at NASA or any space agency knows that next. That has always been a factor for landing manned missions on the planet. But it's been popularized to the public because the Curiosity rover was going to execute this new maneuver where it landed this one-ton SUV on the surface by this new landing method. And that's got everyone running wild because, like, at first we all knew that the Viking, as anybody who's been around for a while, that the Viking landing architecture is the same one we've been using since the 70s. It's how actually Curiosity used it too. It's just in a different, it was wider and had a different, uplifting variation. But otherwise, all these missions have been more or less the same in how they re-entered the planet. Next. And it's considered, went over one time. And also that previous missions landed below 0 kilometers and MOLA, and that's called the Mars Orbiter Laser Altimeter. And for that, it's sea level. And as you know, if you see on a geographical map or topography map, that most of these landers most of these rovers have been landing below 0 kilometers because of the increased atmospheric pressure below 0 kilometers. So where the seas were, and you can see like where the Viking and Pathfinder, you actually realize that they landed deep in a non-existent sea, basically, and that they were 4 kilometers below where actual sea level was. Next. Now, here's the implications and trade-offs for having these. So that's a cool one. That's the ESA IXV. Now that's a working developing a working prototype for using a lifting body aeroshell to use here on Earth, and that could be just as applicable to Mars. And I'm confident in that idea to be using the aspects of an airplane through a planet instead of just having to shoot straight to the ground and hope to God you make it. That you can actually implement the aspects of flight and setting yourself up for a landing before deploying a rover or whatever it was. You have a greater chance of actually landing that mission. So next. And then you have the Red Dragon, which is going to use solely retropropulsive maneuvers and the drag chutes. Next. And you see here the cool part of these two concepts is that it created a smaller landing ellipse, the ability to glide across the atmosphere, proximity landing, which is very much an important aspect for manned missions, heavier payloads, because they would have to bring those payloads steadily and again, increases your chances of actually surviving this ordeal. Instead of the 7 minutes of terror, it's more like the 15 minutes of getting ready to land. That's a good implication. That's a good way to look at it. And the cooler part is that these two concepts are already in development, so I'm not just spitting bogeys. These are actually in development, so that's really cool. Now the only trade-off, next, is that there's no parachute. Because of the weight of the aeroshell and the fact that they're probably landing heavier payloads from here on out, that we don't have the technology to land up. We don't have proper parachutes that could withstand Mach 3 above, let's say, 3,000 pounds of payload. So that's why we have to resort to flight and retropropulsive maneuvers to landing on the surface of Mars. And because of these risks, this is why robotics is paving the way for assuring safety in future missions using this concept. Next. Here's a cool one. It's the Martian International Space Station, MISS. And this interplanetary space station would be launched to Mars together with a fleet of robotic spacecraft, as opposed to the ISS, which was brought up by, there was Zarya, and then you had the space shuttle bringing up components. So it was still a manned interface built in the space station. Here, it would all be robotic and remote. They would be working alone. You could probably use longer-term trajectories. You could use a 4-year trajectory to get to Mars if you really wanted to get the payloads out of there, instead of waiting for the 2 planets to line up. And since there's no one on board these habitable modules, you could probably, spend the time waiting, assuring that you'll all be able to get those components together in one piece. And you see a bunch of systems that would already be on board, now already being robotic, pseudo-robotic space station. And it could do a bunch of remote missions as well, but it would also be prepared for manned crews to come and rendezvous with the station whenever that will happen. Next. Role and capabilities. And that it would be a transient waypoint for manned missions to Mars. It would provide supplies, power, increased communications, and data streaming capability. These are all major pluses because in the event of problems back on the surface, there will at least be an asset on in orbit to report these problems. And an orbiting base to provide real-time control of future unmanned missions to Mars. Well, that's really cool. You could, instead of waiting 8 minutes, you can have someone there saying, "Hey, we made it." First one to know. And so, and lieu with that, you could do scientific missions on the space station. You could do in-situ resource utilization. Let's say it was around Phobos. The previous guy that was here saying that we should go to Phobos and land on and build stuff around it. He has a point. Or an emergency rendezvous point if a manned mission were to go RE or critical on the surface, can conduct expansive exploration to Phobos and Deimos in the idea that it had its own orbit and would have its own little tugs or little manned spacecraft to go to the other moons, or as an Earth return vehicle drop-off point prior to a surface insertion. So anyone with a giant ship can dock at this and assure that there actually be a crew to watch over it, as opposed to just leaving it in orbit for 2 years and then if you were to cold start it and leave it in hibernation for whatever reason, that it would all go well. It wouldn't be there. It lowers the risks of a long-term mission on the surface of Mars. Next. And that's what it looks like. And the cool part, and how it's fine. Okay, so as you're getting back to that, is that you saw briefly the 3 radioisotope power systems. Now that's how, if you're wondering how we were going to able to do all these energy demanding things like streaming more data or higher power communications, is that while there are solar panels available, we'd be more apt to using a nuclear battery, as they could probably complement or probably work out those capabilities better. Consistently, too. Next. And the station expansion opportunity, so it would act like an open architecture approach, which I think, like an open source Android phone, this space station would act in a similar way, adapting software, adapting structures. So we look at Skylab 2, which is a very cool concept. We're using private entities or government agencies want to use Bigelow to expand the space station, and as I would like to believe, since 5 minutes left, 10, perfect. Okay, so we're almost done, and the ability to expand the space station at no expense of being heavier because of the station, but also that because of Mars's reduced gravity, that it would last. The orbital decay, fuel requirements to keep it in orbit is very minimal. So this thing can continue growing at no expense to falling back to the planet. So you see that modules, docking nodes for ERVs and landers, increased crew capacity, I showed you Skylab 2, Bigelow modules, and other long-term-based space station architecture for manned habitability. So that could be observatory-type modules with remote satellites for higher or farther orbital position. Now, that's kind of pretty complex. So think of think of like a Hubble placed on Mars, and there would be real-time control from the space station, so you can look farther or to other parts of the universe from Mars. It'd be something to do. Not gonna lie, it'd be one more thing to do on Mars. It'd be motivating. Next, keep going. Here's the cool one: is that this dust storm simulator. I told you two things. I told you about the station that would be a long-term capability. It'd be a long-term goal. You have entry, descent, and landing, which is an ongoing project, and then you have a near-term. This could be done tomorrow, for all you know. And that this dust storm simulator, I believe, and that it's the three that developed this believe that like an arena of sorts, like a Thunderdome or Hunger Games, and that this simulator would allow for many technologies to be improved on rovers, suits, landers, spacecraft to endure an actual dust storm as it would on Mars. Let's see what it looks like. Not that, but we're doing our best to replicate that. It sounds nasty, but it would actually be very useful. Yes?
You're aware that dust storms involve the whole planet at one time.
Yes, I'm aware of that. We do our best to replicate that as best we could.
Is that from there?
What's up?
Your picture.
No, that's probably CGI. That's not an actual picture. Next. And how it works. So the size of the arena would vary depending on the initial purpose of testing, different kinds of hardware or materials. Again, rovers, materials, people, no, not people, suits, landers, halves. Whatever's intending to land on the surface would have the opportunity, depending how big on the arena is, would have the opportunity to endure a dust storm and see if things would actually survive or any flaws in the design that the firm is submitting to be tested. Observers from outside can view the scenario at hand as the simulator is a closed environment. Various tasks, if it's a rover or a person, okay, if they really, they have, if they're edgy like that, they could go inside and do various tasks to be executed during a storm, and then once complete, the hardware can be extracted from under the simulator. Next. So the implications of feasibility allows for more rigors to be tested on robotic or managed service hardware. The frequency of use are potentially high depending on the scale of programs or missions under development going to Mars. Valuable data can be gained through consistent testing and can be used for tourism and allow public experience whoever this weather phenomenon firsthand. That'd be pretty cool. Not really, but it's an idea. It'll bring money in for sure. And these two other concepts that are coming in, we already know that Robonaut 2 is being tested on the International Space Station. And at some point, when the software improves or he gets new hardware, Robonaut 3, for all we know, could be that asset on the Mars International Space Station, working with manned or itself to keeping the space station space-worthy. And you see the little Prince robotic greenhouse concept is designed specifically designed to help future exploration and expanding the population on Mars. This robotic concept can carry out and take well care of a plant inside the glass container, which is functionality mounted on a four-legged pod. Now, how that gets down there, I do not know, but it'd be a nice idea for a manned mission to bring those along. Next. And these other ongoing robotic concepts. Now, I think this should be more for, and who knows, it may be a thing for future missions around Mars in the future. Yeah, ongoing missions will generate more debris around the planet, and we have the same issue that we do here on Earth. And that these concepts are just as applicable to Mars at a certain timeline. Next. And on-orbit servicing of these concepts would be available through the Mars International Space Station or as self-entities, as is making their own orbits. Next. And the conclusion is, robotics will continue to play a significant role here on Earth and the red planet. Limitless ideas and innovations are still available to be applied for Mars missions. Applicability and cross-compatibility with other deep space missions is always a possibility with these things. Whatever's going to Mars could probably work on Europa mission to Titan. Anything goes, basically. It's important to continue using robotics to test theories and apply them into practice before being done by humans. Again, the aeroshell concept and using the aspect of an airplane. We can do it here on Earth, let's try it on Mars, see if it works. Because that would bring a lot of other good things. Discoveries on new worlds and new environments by space robotic explorers add to our knowledge of the solar system. Space robotic technology helps us to overcome several challenges in Mars exploration by the coordination of massive numbers of robots and rovers. It's always a good thing. It can never hurt to have more. And this will be the test bed for future interplanetary, automated, or human missions. Next. And this must be their mission goal. This company, or maybe what they're doing next. Again, it's ongoing. I don't get so much information from these people. And so acquisition, telerobots, advanced camera systems. So it looks like they want to make a foothold in the space industry. So it sounds good from India. So they're taking on a new market in their own country, which is a good thing. Next. And thank you very much. Do you have any questions? Hey,